Bienvenidos a Alimentos y Emociones Podcast. Comer es inevitable. ¿Cómo comer para saciar mi apetito? Es una elección. Soy Claudia Unot. Acompáñame a hablar sobre temas de conducta alimentaria, de la relación emocional que tenemos con los alimentos y cómo satisfacer uno de los impulsos más fundamentales que tenemos en nuestra vida, nuestro apetito. Today I'm really happy to present Dr. Clare Llewellyn, an Associate Professor of Obesity in the Department of Behavioural Science and Health at University College London, where she leads the Obesity Research Group and the Gemini twin cohort, the largest twin study ever set up to study genetic and environmental contributions to early weight gain and eating behaviour. After an initial career in the pharmaceutical industry, she retrained as a psychologist, undertaking an MSc and PhD in health psychology at UCL and postdoctoral training at UCL and King's College London. Her research interests focus on understanding how genetic and environmental factors interact to influence weight gain, eating behavior, and eating disorders, and to develop novel obesity prevention intervention. As part of an MQ-funded fellowship, she is examining the links between childhood appetite, parental feeding practices, and the onset of adolescent eating disorders. With support from the UK Medical Research Council, she is developing a digital obesity prevention intervention focused on infancy with colleagues from the University of Cambridge. She leads the Environment and Behaviour Work Stream for the UK Obesity Policy Research Unit, funded by the UK National Institutes of Health Research. She also holds funding from the EU, the UK Economic and Social Research Council, and the UK National Institutes of Health Research for research into links between early diet and weight gain, social deprivation and childhood obesity, and parental feeding practices and child eating behavior. Clare is passionate about science communication and has published 2 evidence-based practical books for caregivers about feeding during the early years, Baby Food Matters in the UK and An Appetite for Life in the US. Let's welcome her to talk about the Behavioural Susceptibility Theory. Hello, everybody, and welcome back to this 3rd season of Alimentos y Emociones podcast. It's really, really exciting for me. The last week, I just did a little section myself just to introduce this season. But now we come on to the big major league guests, and I am so excited to have Clare here with us. Clare, welcome.
Thank you, Claudia. I'm really, really excited to be here and chatting to you as well. You know how I always enjoy our conversations on this topic.
Yes. And we seem to have had...
comes out in force.
And we seem to have had the opportunity, which has been great. I spoke about you, since last week, and I was just saying how, I met you in 2012 when I came to do my PhD, and unfortunately, you weren't one of my supervisors for my PhD, but it was as if you were, because I think all those hours of,
in spirit.
all those hours of spending a lot of time doing PCAs on the floor with you was like,
I do remember the wall size PCA output printout on our office floor.
Yes.
Trying to make sense of your questionnaire design for your
exactly.
PhD.
Yeah. So, and I always remember what you said, Claudia, just remember it's not an exact science. So we have to sort of work, at how this is going to work out. But anyway, so this brings me to this really important conversation, which is to talk about, in general, about the behavioural susceptibility theory of obesity and your work in it, what you've done, how you came to it. So if you want to start from how you started in this work, that would be wonderful.
Okay, so I am a psychologist by background. And I came into psychology actually from pharmaceuticals. And I remember starting my master's in health psychology here at UCL. And originally, I was supposed to be doing my final, well, it's not really final, it's my dissertation in, it was actually in HIV and sexual health research. But what happened was the ethics application to do the focus groups got delayed. And it just looked increasingly more difficult to do the research. And so at the time I was volunteering with my, who then became my mentor, the late Professor Jane Wardle, who was an incredibly sort of charismatic, interesting, and very sort of passionate and enthusiastic professor in the field of eating behaviours, and a very big presence, as you'll remember.
A powerhouse.
A powerhouse. But she had this sort of way of any conversation you had with her felt almost life-changing. And that sounds so ridiculous, but that's sort of how it felt, especially when I was a very early career researcher, just, you know, a master's student just starting out. And I would have these conversations with her about her research and child eating behaviour. And I told her about my worries about my ethics application for the project I was going to do, you know, all falling through. And she said, well, listen, I've got this incredible data set on children's eating speed. I've got nearly 300 videos of twin children sitting and eating sandwiches and fruit together in pairs. And I'm just really interested in whether eating speed is genetically influenced or not. Would you want to have a look at that for your master's program? And there'll be no ethics issue because, you know, that's all been done and the findings of that. Well, the data are there. So I obviously jumped at the chance. And so very luckily for me, there was a really committed and competent research assistant in the department who had painstakingly coded all of these videos already. So she sat and she watched pairs of twins eating sandwiches and fruit for their lunch. And she basically put a line in every single time a twin took a bite so that she could code each single bite and how many bites per minute they were taking, and did all this incredible coding of the videos. So I then inherited this amazing data set, and that was the very first bit of research really that I did into eating behaviour. And this whole world exists, which I had no idea about, of eating behaviour. And there's all this incredibly complex terminology about it, and they have these incredibly sophisticated bits of equipment. And so I became incredibly obsessed with something called the microstructural analysis of eating behaviour, which is how you sort of can deconstruct the tiny minutiae of ingested behaviour, like, you know, bite size, eating speed, satiation curves, and that kind of thing. And these videos became my whole world for a few months while I just sort of immersed myself into the field of eating behaviour, which actually has a really long history. I mean, you know, there's sort of 50 or 60 years of people dedicating their lives to studying how people eat. And I then obviously looked at a lot of the literature, and Jane directed me to some of the early seminal papers, which is just so fantastic and so interesting to read. And I still now would always encourage my students to read some of the really early seminal papers, where they're just such sophisticated experiments that they did, and they're trying to understand.
Do you remember some authors? Because that's interesting for some
Albert
people.
Stunkard was a really key person in the field. I can actually, I'll as we go through, some names will come back. But yeah, so that was sort of how I fell into it. And then I did my master's project on this. And I mean, I have to say, I just completely fell in love with the field as soon as I started researching it. And more than that, it was just so fascinating. Yes. Everybody eats.
Yes.
Right?
Yep.
Everybody eats, and everybody thinks that they have their own particular style of eating, and everyone likes to talk about it.
Yes.
And it's a real topic of conversation, and people always talk about their kids eating and what they're like. And, this one has a really big appetite. He loves his food, really looks forward to his meals. My daughter's really fatty and she won't eat anything, and it's a constant struggle. And it's always a worry. So these are always conversations that people have had.
Is that how Gemini sort of was born?
So Gemini came about because Professor Jane Wardle had done lots of sort of smaller, more behavioural experimental studies for her research. Sort of, I suppose initially she started out as a clinical psychologist and actually started out in eating disorders research, and then she moved into sort of how eating behaviour varies across the population of healthy children and adults, and how that might be related to just variation in weight. And so she started off sort of studying these eating behaviours in relation to weight using really sophisticated and quite detailed measures in the lab, and then in schools and sometimes in home settings to make it more ecologically valid. But she also was working in the field of epidemiology, which was kind of what makes her and Gemini quite unique. Yeah. And so she realised that actually to be able to derive reliable associations between eating behaviour and weight, whatever other outcome you're interested in, you need really large samples, and you need a really reliable measure that is measuring exactly the same thing across different samples and different situations. So you're trying to get at the trait rather than a state of hunger or illness or annoyance or whatever it is that you're measuring in the lab at that particular time. And so she decided that what she wanted to do was she wanted to be able to look at the relationship between eating behaviours as early as possible when they start to emerge in infancy, and how they relate to weight gain. And in particular, she was interested in obesity risk in childhood. She was also very interested in where these eating behaviours come from. So she was aware that researchers who looked at infants before, not many studies had, but the studies that had looked at infants, were seeing really big differences between babies. I mean, even in the first 2 weeks of life, some babies would suck really avidly in response to milk that was offered. And some babies would sort of suck on and off, weren't particularly interested, would fall asleep, kept having to have their toes tickled and, fan put on them to encourage them to
careful.
Yeah, exactly. And, those differences in how they responded to the opportunity to feed were related to their rates of weight gain over 2 years. So Jane was thinking, well, how can you see differences in these things so early if it's all caused by parents? Because, of course, everyone assumes that the way that children's eating behaviour develops is largely shaped by the way that they are nurtured and fed by their parents and parental feeding practices, policies, food availability, and so on. And so Jane said, well, maybe they're just sort of quite innate. Maybe they're quite genetically influenced and they're just there. And what we see is the unfolding of things. And maybe the way that parents feed their children are just as much of a response to the eating behaviours that their child is expressing more and more as they get older, rather than, or as well as, an effect of the way that the parents feed the children. And so she decided that the best way to do this would be to start a large population representative cohort of twins called Gemini, and she would recruit the sample from the Office of National Statistics in the UK, who would write to every single family in England and Wales who had twins in 2007, and basically say, we're starting this really important twin study. Can we have your details? Would you like to be part of it? And then all of the families whose addresses we got sent were sent the baseline questionnaires, and 2,402 families responded to the baseline questionnaires, and they became the Gemini sample, and they're still the Gemini sample today. So
in
they're now
2007.
2000. So they were recruited in 2007. They were born in 2007 between March and December, and so they are now. I mean, you can do the maths.
No. 14.
Quite stressful doing this, you know. They're all older. So
working it out.
13, I think. Gosh, are they even 14?
No, they're 14, Claire.
14 because we're in 2021.
Oh, yeah.
Yeah. That's so good. So actually, they're 13 turning 14.
Yes.
So the youngest ones will turn 14 in December.
Yeah.
That's really incredible, actually. And so we actually collected the last round of data collection in 2019, 2020, when they were sort of 12 to 13 years old. So that's incredibly exciting. And they were still reporting on the same sorts of eating behaviours that we collected when they were a few weeks old. So we've been tracking their eating behaviours for the whole time. So that's Gemini.
But now, it's just become the largest sort of cohort in the world that has, information about eating behavior and growth in infants, and children. It
is, which is incredible, really. So it's the largest twin study ever set up specifically to study genetic and environmental influences on early growth,
right?
With a focus on eating behavior. And actually what makes it so rich in terms of the growth data is that so in the UK, babies get weighed. Okay, let's ignore the global pandemic that probably interrupted that over the last 18 months. But in 2007, babies, and particularly twins, because they're born small and early, and healthcare professionals like to keep an eye on them. Mm-hmm. So they are weighed very regularly by healthcare professionals, and the weights are written down with the date in what's called the Red Book, which is their health record. And at baseline, we asked the parents to send in photocopies of the health record with all of the weights that were ever taken over the first few months that the parents were recording them. And then we sent the families weighing scales and height charts, and they've been taking the weights and heights of the children every 3 months themselves. So during the first sort of year or so, some families have 70 different weights for the twins that they sent in. And I think the average is maybe 5 or 6. So it's really, really detailed. And it's lovely because you can kind of look at growth trajectories, and we've been able to characterize what growth looks like in infancy in such a detailed way. And we work with...
You're salivating, Claire.
I am salivating. I'm just thinking about the SITAR parameters. So Professor Tim Cole, who's based at UCL in the Institute of Child Health, is a statistician, and possibly
very well known.
Yeah,
in the nutrition world, definitely.
one of the most prestigious professors in the area of child growth, and he developed the growth reference data that was used in the UK for years, and the WHO growth curves and so on. So we were so lucky and privileged to have Tim Cole work on the Gemini growth data to derive what are called the SITAR parameters, which are 3 different aspects of growth that he was able to derive from the data in Gemini. So one is its size, velocity, and tempo, basically. So size is just on average, how big was that baby? How much did they weigh relative to all the other babies in the sample over the first year? Velocity is during the period where they grow most quickly in the first 6 weeks, where there's a real kind of almost an exponential increase in weight gain. What was the kind of the gradient of that growth velocity for each child? So was it faster or slower than other babies in the sample during that time? And then tempo was, when did that really speedy sort of growth velocity happen? Was it earlier or later than other babies in the sample? And Tim Cole thinks that probably relates to even things like age at menarche later, and may even be a really early indicator of sort of biological age. So we don't really know at the moment, but these are the parameters that he derived. And so we've been working with those.
Amazing.
Yeah.
What are some of the results that have come out of all this data?
Gosh, where to start?
And how many people would you like to recruit still to come and help you to analyze a lot of it?
How long is a piece of string? So we're constantly, so part of my job is constantly to be writing grant applications to try and get more funding, to get more people on the ground, really, to help run this study. And because so much of it now is trying to keep the families engaged and, you know, interested in continuing to participate, fill in these lengthy questionnaires.
Cheerleading.
Yes, exactly. Telephone interviews, things like making the website look really enticing and keeping it up to date, the Facebook page, the Twitter page. So all of that stuff involves quite a lot of administrative work, really.
Yeah.
But we've always had, even when the team's been thinner, we've always had such dedicated, committed people, often in the form of PhD students. And for a period of time, Gemini was pretty much run by the PhD students who were just—
As you were yourself in the beginning.
Yeah, exactly. Yeah. And I personally entered, I don't know how many of the baseline, we had 4,808 baseline questionnaires to fill in. And we did that as a team by hand because they were hard copies at the time. We didn't have an online questionnaire.
Yeah.
But actually, it was such an important part of getting to know your data.
Yeah.
And, you know, we devised the questions together. So that was quite exciting as well. I have to admit that I'm not the best data entry. I'm better ideas than an eye for detail.
Yeah, we like to save your brain for the good ideas, Claire.
I was always in trouble with my supervisor for making errors and having to go and do it again. But yeah, so that's Gemini. And so yes, I would definitely always like more people. But in terms of the results, I guess maybe I'll quickly summarize behavioural susceptibility theory, and then I can explain what we found in relation to that. So Jane set up Gemini, as I mentioned, to test what she called behavioural susceptibility theory. And so she hypothesized that the genetic influence on weight, which is very well established and very strong, so we know from decades and decades of twin studies and now genomic studies that between about 40 and 70% of individual differences in BMI can be explained by genetic differences between people. So that doesn't mean that 70% of my genes are influencing my weight. What it means is where you see variation in the population, genetic differences between people are more important in explaining that variation than perhaps other factors. And then genomic studies have come along since then, mainly in the form of genome-wide association studies, and they've started to identify some of the common genetic variants that are actually involved. And so that sort of research field has sort of led to quite a few questions, really, especially among behavioural researchers, which is, how can there be both strong genetic determination of weight when it's so obviously environmental? You know, it sort of created this seeming paradox of what the causes of obesity, because the gene pool hasn't changed in, 50 years. It can't change in 50 years. That's obviously ridiculous. So how we can't possibly say that obesity is genetic when the genes have remained the same and it's only the environment that has changed. And so this question was sort of, I think, on Jane's mind and everyone's mind, and still is on our minds, and how it's all working, and how the two, both the environment and genes, are working together to influence obesity. And her hypothesis was genes are influencing weight through our eating behaviour or our appetite. So individuals inherit a set of genes that can give them a bigger or smaller appetite, to put it very simply. And the individuals who inherit a really avid appetite and who are very susceptible to wanting to eat when they see, smell, or taste really delicious foods, have very, very weak internal sensitivity to satiety, those individuals are much more susceptible to the current obesogenic environment, with the multiple opportunities to eat being bombarded constantly with food advertising, food availability, it's very cheap, readily available, long shelf life, etc. And on the other hand, individuals who inherit a set of genes that give them a really small appetite, completely no interest in food whatsoever, only want to eat when they're hungry, those individuals are protected against obesity in the current environment. It doesn't matter what environment you put those individuals in, they're probably just going to eat what they need. And then their biology will take over. And when they're full, something in the brain, in the reward center, will switch off and say, actually, that food's not nice anymore. I'm feeling a bit sick. I'm going to stop now. Or I'm feeling really uncomfortably full. I really don't think I can eat anymore. So they're the sorts of biological mechanisms that Jane was hypothesizing probably have quite a strong genetic basis.
Yes.
And then when you change the environment hugely and you create an environment that is really full of palatable foods that are readily available, and you're constantly probing people and inviting people to eat, you're going to start to see really big differences between people in terms of their genetic susceptibility to obesity. So what you'll see is that the individuals who are genetically susceptible will gain excessive weight and the others will remain lean. So the way that she always put it was, the genes load the gun, the environment pulls the trigger, or the environment is acting as a volume control for the genetic expression. And to test this hypothesis in Gemini, she wanted to do mainly two things. One was to look to see whether these appetitive traits, if you like, have a strong genetic basis, as she hypothesized. And the second was to see whether these appetitive traits do genuinely seem to play some sort of a causal role in weight gain and obesity risk. And she could do those two things because Gemini is twins, and you can look at the heritability, and it's longitudinal. So she could look to see whether appetite measured during the earliest period of life could predict the rate of weight gain going forward. And what we found was in the twins, we were able to measure using a questionnaire measure of appetite called the Baby Eating Behaviour Questionnaire, which I developed as part of my PhD. And there were 4 distinct eating styles in babies during the earliest period of life, during the period of exclusive milk feeding, before any solid food's been introduced. We're talking about young babies.
Less than 6 months old.
Less than 6 months old, yeah. And actually, I think we said in the questionnaire during the first few weeks to kind of focus their recollection of the early feeding period. And there's 4 areas that we could measure eating behaviour in that were different, and there were massive differences between babies in these. So one is food responsiveness. So that's really how demanding the baby was regarding milk, always demanding a feed, no matter whether you've just given them a full feed. If you offered them again 50 minutes later, they'd have another one. Satiety sensitivity, which is how easily they fill up during feeding. And then there was slowness in feeding, which is literally how quickly they milk feed. So some babies will finish the feed in 5 minutes, others will take 45 minutes. And then there was enjoyment of feeding. So is feeding a calm, an enjoyable process for the baby, or do they find it quite stressful and do they not seem to enjoy it? And we were able to use the twin design to look at the genetic and environmental influences on these 4 aspects of appetite. And the reason that you can use twins to do that is because they're kind of like the perfect natural experiment. So identical twins or monozygotic twins are 100% genetically the same. Non-identical twins or dizygotic twins or fraternal twins are on average about 50% genetically the same. But the key thing is that both types of twins share their environment to a very, very, very similar extent, insofar as they're gestated in the same mother for the same period of time, they grow up in the same home, they tend to go to the same school or the same socioeconomic status, and so on. So that means that you can compare how similar the two types of twins are. And if the identical twins are way more similar than the non-identical twins, we assume that can only be because they're twice as similar genetically, because everything else remains the same. So you've basically got a control group.
Yes.
And so what you do, the sort of quick and dirty method in twin modeling, is you correlate your identical.
There is no quick and dirty method in twin modeling.
That's actually true.
I'm glad you think of it that way, when you always
start with the quick and dirty, and then you slowly move on to R. Path analysis and your maximum likelihood estimation, which is a bit tricky. But basically, you can correlate your identical twins, and say you get a correlation of, I don't know, like 0.6 or something for food responsiveness. And then you correlate all your non-identical twins, and you're like, oh, I have a correlation of 0.3. And what you do is you look at the difference in those correlations. So that would be a difference of 0.3, and you double it, which will give you an estimate of 0.6. And that's your estimate of heritability. So that would indicate that if you have an identical twin correlation of 0.6, a non-identical twin correlation of 0.3, that suggests that 60% of differences between babies in food responsiveness are attributable to genetic differences between babies. And you do use, as you mentioned, some quite crazy statistical modeling to then derive really precise estimates. And what's quite cool about twin studies is they don't just tell you about the genetic influence, but they can also partition the environmental influences into those that are completely shared by two twins and contribute to their similarity, and aspects of the environment that are unique to each individual twin that make twins different from one another. So an example of a shared environmental effect might be gestational weight gain in pregnancy, or gestational diabetes, or the fact that they were both breastfed by the mother, or they received the same breast milk, for example. An example of a non-shared environmental effect, or a unique environmental effect, would be one baby got quite ill in the early weeks of life, and they ended up having to be tube fed for a little bit, or it just really affected the development of their appetite. But the other twin remained on the same trajectory. So those twins would become different from one another for a random non-shared event. So the analyses that we did on the BBQ were quite extraordinary. And we discovered for the very first time that the individual differences in appetite in infancy are largely influenced by our genetics. And this was quite a controversial finding, which I didn't realize at the time. Genetics is quite a sensitive topic,
yes,
and it can be quite an emotive one, and I think people sometimes worry that it might become deterministic somehow.
Yes.
But which is something that I always like to address in talks and in papers, so I might say a little bit about that now.
No, please.
So twin studies, what they tell you is that in this particular population right now, where there's been no intervention, we're just looking at how things are in a naturally occurring environment. What we're seeing is a large proportion of individual differences can be explained by genetic differences between children, and a smaller proportion by the environmental differences between children. But genes are not destiny by any means.
Yes.
And the genetic effect changes. It's different in different populations.
Or stages of the life course.
Exactly.
Yeah.
It can change hugely. It can change due to an intervention. So we found we ran an intervention study in Gemini, which I'm sure Dr. Alison Fildes will talk about in more detail, that she ran.
Yes.
Her PhD. And we found that the genetic influence on liking vegetables changed before and after an intervention. And what we also found in Gemini was we measured the home family environment in incredible detail, and we were able to divide the families into the families living in a higher risk for obesity home environment and the families living in a low risk obesity environment. And the genetic influence on BMI for 4-year-old children was 40% for those living in a low risk environment where there were a lot of sort of parental sort of policies. It was very around food and drink and physical activity and media use, and it was quite structured in terms of eating patterns and things like that. And in the higher risk obesity environment, the genetic influence on BMI was 80%. In fact, it was over 80%. So it was more than double.
Yes.
So that sort of really indicated that the environment is sort of the cause, because you can't do anything about your genetic predisposition, but it's just a predisposition.
Yes.
It's not the end result.
Yeah.
And actually, the environment that you grow up in and the events that you experience and your journey throughout life is how your genes are expressed. And that will be the kind of the door opening, if you like, or closing on genetic expression over many years. But I do think that what genetic studies can tell us is that some people are just much more vulnerable to the environment than others. And it's not easy for some people to maintain a healthy weight, lose weight. It's incredibly hard because you are, to some extent, battling your biology. I think these studies also help us to give people concrete advice about the sorts of things that it's common to struggle with when you're struggling with your weight. So we know that genetics are playing an important part. And for some individuals, there are reward processes in your brain that respond to the food environment differently to someone else. And it's much more enticing and it's much more difficult to resist. There's certain biological processes that you're not able to do so much about in terms of the starting point, like your internal sensitivity to satiety, but you can maybe pay attention to them a bit more. And maybe you just need to be more aware of how much you serve yourself with a portion size and be guided by those sorts of environmental factors. So I think it's quite important to understand how the genes are influencing our weight or predisposing people to obesity, to then kind of understand which environmental factors might be important in focusing on and helping people to understand why they are the way they are. I think that's a really important part.
And I think that in sort of public health policy as well, when it comes to nutrition and the environment, we always concentrate on like food labels and etc., or calorie content or all these things, but this area of eating behavior, because of the data that you have, I think it is also really important to, as a public health policy, to be able to say, learn to read your own internal sort of, satiety cues, basically.
And also, to say to supermarkets, if you load up your checkout with confectionery, then some people are going to find that very difficult. Or they're going to have a child with them when they're queuing up. That they're going to end up buying something that they never intended to, and that's unethical and it's not fair. And actually, in terms of
it's not just a nutrition thing. That's what that's why I went into that area as well. But being a dietitian, everyone thinks you just got to talk about food, and that's not. So this eating behavior to me is like just richer.
It's also it really influences how clinicians might think about weight loss and managing patients, because the advice to just eat less is completely unhelpful. You have to help people work out how to eat less. What are you going to do in this, that, and the other? situation when you're surrounded by palatable foods that are going to be triggering your reward system.
Or the work that we've done together as well, Claire, which is, measuring now that we can, like the children and the mothers.
Yes, absolutely.
And then if there is a genetic component, then we can sort of ask the mother to, look at her own cues and the child's cues, and then we can do sort of interventions that are a bit more family guided,
Absolutely. And it's funny because the findings that we've just come up with, which I don't know if we're able to talk about now because they're not published yet.
Nearly.
Just seeing that mothers and their children do resemble one another for eating behaviours. That also does fit in with a wealth of research that shows that family-based interventions for childhood obesity are just so much more effective than focusing on the child alone.
Yes. Wow. Well, hang on, I'm going to just pop in over here because I didn't bring them down, but I do want to show everybody and put the link, but your books.
Ah, yes.
Have them both. But I think this is important, why measure appetite? So this one is the English version, the one Baby Food Matters, and this is the American version, An Appetite for Life.
Although the English publisher has just changed the name to An Appetite for Life, so they're both called An Appetite for Life.
Okay, sorry, I've got the older version. And what do you talk about there? Well, I know, but
So in the books, what I wanted to do was to be able to put into accessible information, really, translate the research that we've done into practical and accessible information for caregivers. So I think a lot of science that's really good and really important and really valuable for the wider public ends up in these obscure academic journals that cost an absolute fortune to access, unless you wait 20 years when it becomes, available. And so A, it's often difficult to even get hold of the research, and B, you then need a science degree or
to interpret.
To be able to interpret what's in the paper. So I wanted to take what we know about appetite, eating behavior. There's also nutrition in there because it's also important.
Yes.
But it's all important. It's, they're equally as important. And I think also there's a lot of sort of one size fits all advice for parents around how to manage your children's eating behavior, but less advice for what to do if you've got a really, really picky eater or a child with a poor appetite whose weight gain is slow and you're worried. And also a child who just seems to want to eat all the time, is very food responsive, eats quickly, in low sensitivity to satiety. What does a parent do in that situation? It's really, really challenging. And it's really sensitive. And parents, understandably, also worry that if they are too focused on their child's eating, they're going to create an issue around it, and they're concerned about eating disorders. So the book focuses on what the research is in relation to these, to make it clear to parents that children are all different. And they're quite different from the minute they're born, actually. And the vast majority of differences between children have got nothing to do with the parents, which can be a
relief
or positive. It can be a relief, though.
Yes, it can, because we blame ourselves.
I know, and it's very pressured. But actually, there are definitely things that you can do that can help. But if you've got a really picky eater or a child who wants to eat all the time, that's not your fault. That's just because children are different from each other. And in the same way that shoe size differs and height differs. Variation is the way of the world, and variety is the spice of life, and it's what makes the world so interesting. So just to put some practical tips in there to help parents manage different types of eating behavior, and also really just to try and reassure parents that most of the time it just doesn't really matter, and it's just about not being too controlling with your child's eating and trying to give them some autonomy within obviously a range of healthy choices and being a parent about, you know, the food that you provide, and just letting children develop as they're going to develop, and enjoy meal times as much as anything.
That's the book, and I think I could stay here for another couple of hours and talk to you about all of this. I hope that everyone has enjoyed this. Claire, I really, really thank you for your time. I know this
thank you for inviting me, Claudia. It's been lovely. It's always lovely to chat to you. And we always talk for hours.
I know. I'm going to obviously leave all of your details, below, your Twitter account and everything, and your books and links to, key papers.
Lovely.
And I hope you can come back one day and we can carry on chatting about this. It's so, so important. And thank you for being the first guest and for opening this topic up so that we can have...
What an honor. You're very welcome.
It's absolutely wonderful. And to everybody, please share this podcast with anyone who you think might enjoy it. And I'm just going to say it in Spanish. Nos seguimos nutriendo, and in English, we continue to nourish each other. So we'll see you next week. Bye-bye.
Okay, bye.
Nos vemos en un próximo episodio de Alimentos y Emociones Podcast. Y recuerda, nos seguimos nutriendo.